Oh,
Yeah, here we go.
hello everyone, and welcome back. I'm here with Florent Biville, who is a polyglot developer on the official Go driver for Neo4j, the leading graph database. And he's here to share a talk with us. And he's actually going to live code, so I admire his bravery. Take it away, Florent.
All right, thanks for the kind introduction. So let's share my screen, and here we go. So hopefully you all see my slides. So thanks, welcome to this talk about graph databases. So what we're going to do today together is learn about what graph databases are, how we can, use them, so model data, etc. Learn a little bit about how to query, that can be useful to read data from and read and write data to databases, I heard. Then we'll dive right into the live coding, show a little bit how the Go driver works. And yeah, that will be mostly my talk today. So of course, if you have any question, I believe you can use the Q&A. And if I miss some of the question, I'm pretty sure my host will catch up with those and remind me. So let's go. So let's compare, that's a comparison we cannot avoid. Like, how is it different from relational databases, right? Relational databases have been the kings of persistence for so long that I assume most of you are familiar with them. And so I always use the same slides, to be honest, because I think it's very effective. And I tested it against actual colleagues, so not developers, but colleagues from PMs, designers, etc., to try to illustrate the difference. And so my example here is, let's say I have persons and groups. And as developers, of course, we've been working with relational databases for so long that, when I talk about a person can belong to different groups, a group contains different persons, we say, oh, that's a many-to-many relationship, so I will need, a joint table in the middle, and that's how I can represent the fact that a person can belong to many groups and a group can have many persons, right? So that's a representation on the left on my slides. However, when I tried to explain that to my, non-technical colleagues, they were genuinely lost. They didn't get it. And I showed them, the part on the right, which is, let's say you have a graph. How would you model this, this person group relationship? I'm not saying that's the only way to model it, by the way, with the graph database, but that's at least the most intuitive way to go. It might vary with your context, of course. And so in our case, we would have a person entity, group entities, and just links between them. And here you go. And here you go with a model that everyone can understand. And basically what you draw is mostly what you persist. So that's also one strength of databases. It's very easy to model relationships, entities. So networks of entities, really, that's really, really useful way of representing things that is intuitive with many different backgrounds of people. So great, but when we talk about graph, then people, if you have some experience with graph, you might have heard about triple stores. So triple stores are a little bit different. So the way they organize data is so you usually have this kind of technology with semantic web, semantic technologies, etc. So the way it's organized is everything is phrased as a subject, an object, and a predicate between them. And subject and object can be enriched with properties, while predicate cannot. So in a way, properties, so what we call property graphs, and that's what Neo4j supports. Neo4j does not support triple stores, can actually generalize this model. And so that's a model we're dealing with when we're working with Neo4j. So we have what we call nodes. So in the literature, you can heard about vertex as well, but with Neo4j, I'm going to use the word node. So nodes can be linked together with relationships or edges in the literature as well, but I'm going to use the word relationship. So in that example, I have one employee with a bunch of properties, so name, date of birth, and employee ID. I can use a label. So in that case, my node has exactly one label, employee, a bunch of properties, as I said. It's related to a node called, which has a label company. In that case, there is no property to it. And the relationship, of course, has a direction. So the company has a CEO and that CEO also is named Amy Peters. The relationship itself not only has a direction, but it also has exactly one type, and it can have as well many properties, just like nodes. So contrary to triple stores where predicates did not have any properties, relationships in Neo4j can have properties just like nodes. So they really are first-class citizens. And in the same ways, of course, a node can be linked to many other nodes, even to itself if needed. And so in that case, we also know in that very small data set that the company is located in a city. And here we have not detailed, city would probably have some properties, so we know what city it is about. But that's just a simple example that shows the main concept. So nodes, relationships, which have directions, and properties that can be on both. All right, and so how do I model data here? Because of course, I'm just giving simple example, and I'm not gonna spend too much time on this, because of course, every problem is different, every model is gonna be different, but as you know, all models are wrong, but some are useful. So I'll just give you some rules of thumb to try to model your problem with a graph database. I'm not saying that's the only way to do it, but that's a useful way to start and iterate on. And one nice property of Neo4j, by the way, is that it's schema optional. So if I come back to my example here, I could have two nodes with the label employee. That doesn't mean they share the same set of properties. There is no rigid schema. Doesn't mean you have to abuse this and have very different properties between nodes of the same labels, but you can do it. And that's actually quite useful at the beginning when you want to iterate fast on your model and evolve it with your application or questions you want to solve. So that's one good property with Neo4j that you must use with caution over time, but that's another discussion. And so here are my rule of thumbs. So some of them, are very general. It's true for Neo4j. It's true for any data persistence layer you want to use. The first thing is you must understand the domain. That might involve, speaking to stakeholders, speaking to users, speaking to business experts. But yeah, that's usually doesn't work in isolation. You need to reach out to people who know. Then the second step, of course, would be to get some sample data and define specific questions you want to answer. And that's something that I believe is true for any kind of persistence here. And that's something we really emphasize at Neo4j. It's not because it's a database that it should, you should spend months and months and months defining the perfect model that's going to work with every application you have in your company. We really try to encourage, a more agile approach, if I may. Try to come up with specific questions, make up a model based on that, and refine. It should evolve as fast as applications really. So start with a small set of questions and refine your model all the time. Then, of course, will come the graph-specific parts. So what parts of my graph will be nodes, what parts of my graph will be relationships, and then test, once you have your graph, test it again, the model, the sample data set, and then test it for, again, a larger data set if you can. So that's, so let's zoom a little bit about, the graph-specific parts. And that's a rule of thumb, right? That's not always true, but that's always a good way to start when you don't really know how to do. So now that you have specific questions you want to answer with your data set and queries, what we recommend is you start, so you have your questions, try to identify nouns in those questions. And usually, not always, but again, that's a good way to start. Nouns would be your nodes. And if you see some kind of genericity in your nouns, those are good candidates for labels. That means you will have some group of nodes that belong together, and that group name would be a good candidate for a label. Then, of course, you can refine that model once you've started with it, based on your business knowledge, and once you know more about how it fits or not with the queries you want to write. So, for instance, and that's not a 432 example. We're going to work with a movie dataset for the live coding part. So, which actors play in movie X, for instance? So, actor, movie, probably good candidates, good initial candidates for nodes. How many movies did this director direct? So we'll see we had actors, we have now directors maybe also as a concept. and which users rated movies with more than 4 out of 5, 3 out of 5, etc. So you can see how in our first iteration, nodes can emerge like this, Again, rule of thumb, not saying it's always true, but that's a good starter. And then, of course, comes the question of properties. So for nodes, but for relationship as well. But especially for nodes, there are basically two main roles for properties in a graph database. One way is to have a unique identifier. You can think of UIDs, for instance, universal identifiers. Or properties will help either identify starting points for your query, filtering along the way, or projects or results, part of your return clause. So those are the main roles of properties. Otherwise, we say it's decoration, right? It's not directly useful for the purpose of querying or writing data. Then relationships. So we had nouns on one hand for nodes, and verbs usually are good candidates for relationships. And of course, direction, you usually guess it right away because there is some inferred direction, unless it's bidirectional. If it's bidirectional, Neo4j forces you to define a direction anyway, but you can just ignore it afterwards. Just don't define two relationships in that case. Define one, pick an arbitrary direction, and just ignore it when you query. A few warnings though. Avoid very generic relationship types like is, has, etc., because it could be very overloaded and used in many different contexts within your graph. So it will make querying a little bit harder because there could be ambiguity when you query those relationships. Just talking about ambiguity, because of natural language, we have to deal with it. But sometimes verbs are also nouns. So if you can avoid that, that's great because it will be easier to understand what the query does. And the direction, so should be natural mostly, and same, it's true for directions, but it's true for picking relationships and nodes. It should make your queries easy to write. If they are easy to write, they are easy to maintain. So if you struggle with a query, then it's usually worth coming back to the whiteboard and really have a look again at your model and iterate on it. And as I said, avoid symmetric relationship. Like if they are really symmetric, for instance, on Facebook back in the day, I'm not sure it's true anymore, but when you were friend with someone, it was completely bidirectional, right? So you didn't need to say, hey, I'm friend with B and B is friend with me. No, it's bidirectional already, so you don't need to define two relationships. Of course, if you take another example like Twitter, if you follow someone, that doesn't mean that someone follows you. So in that case, two relationships would make sense because they are not symmetric. They don't mean the same thing depending on its direction. And if we look at the same kind of example, if I take the same question, which actors play in this movie? Play is probably a good relationship, and the direction here would be from actors to movie, because the movie doesn't play an actor, or maybe some movies, I don't know, but that would be a bit strange. How many movies did this director direct? So direct would probably be a good candidate for relationships. And same things with ratings. So rated a movie, so we would have rated, and rated could have a property with a rating itself, for instance. That's one way, of getting started, iterating, etc. All right. And so when it comes to testing, so let's say you have your questions, you have a data set, and you're starting to write query, and we'll talk about querying in a short while. Then ideally, not only are queries easy to write, so you don't spend hours and hours scratching your head trying to write your query, but also they should be as efficient as possible. And in the case of graphs, you traverse nodes and nodes and nodes until you get to your results. So ideally, you would get the best starting points for that, and you would traverse as little as necessary to get to the desired result. For this, you have what's called explain and profiling. And so Cypher is the query language of Neo4j, and it includes explain and profile. You just prepend your query with this keyword, and you will get a detailed explanation of the query plan with explain, of the query execution itself. You will get some very precise metrics to know how expensive is your query and whether you can improve it or not. So that's something for a bit later, of course. That's one you have some queries to test, but that's always useful to test, especially against a larger data set. And so let's talk about Cypher and the general principle underlying it, which is graph pattern matching. So Cypher is declarative, which means you describe what results you want, and Cypher will figure out how to get that for you. It's not imperative. You don't have to say, I want to traverse this and this and this and that, and then get that result. No, you describe what you want, and Cypher will do its best to actually retrieve the results. So let's say I'm interested. So colors here are just, for illustration purposes. You can translate that into labels, for instance, not labels. So let's say I'm interested in this pattern. So I have 3 nodes, and they are interconnected like that. So that's the pattern I want to find and want to retrieve. And let's say that's my data set, right? I have some nodes matching those colors and some other nodes that don't. And so if I say to Cypher, please find me this, again, this specific data set, the first thing it will do, it will try to pick the best starting points in my graph to traverse as little as necessary. And then it will try to expand based on what I described and get the results I want. And in that case, you will see I will get exactly 3 patterns matching what I wanted. So that doesn't mean 9 nodes, right? Because you can see there is a yellow node in the middle that is actually part of 2 different patterns, right? But I've got 3 distinct patterns that match exactly what I want, and so Cypher will return me that. And so what you describe is what you get. That's really what declarative query language is about. And so the runtime will do its best to infer what kind of traversals it needs to do. And so Cypher concretely, so that's the principle of pattern matching, but the way you do it, because it's matching, so your select, in a way, select will be match. Then you can refine it, you can add some specific predicates to filter a little bit. Then you will project the result with return, order by, and limit. So that for the reading part of it. For the write part of it, I won't show an example today, but you can use create or merge. And it's the same thing. You will describe a pattern that you want to create or observe, and that's what's going to happen. And the fun thing is when you think about SQL, right? So it's select from where, blah, 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 blah. The actual order in which the execution happens is not exactly the same. So Julia Evans, who is so great at explaining so many things, has this great diagram of how the execution actually happens when you run a SQL query. And it's completely different with the way we write it. And in case of Cypher, it's much more logical in my mind. Of course, I'm biased, right? I work for Neo4j, but still, what you write is more or less the order it gets executed. So there is no such mismatch. And so, yeah, I think that was a useful comparison, really, because Cypher is, in my mind, a little bit more logical as for the order you write things. And so match the pattern, filter if needed, return what you want, and order by, limit, skip, etc. And so let's have a look just as a quick example. I know it's not enough to wrap your hand around Cypher. It would take a little more time, but here I describe a very simple pattern when I have a node. So in that case, I will try to match nodes which have labels person and a single property here. So the key is name, the value is a Dan string. And those nodes must be in a relationship with some other nodes. And the relationship start from those persons to the target node, and the type is loves. And based on that, the Cypher runtime will try to match everything that works. So any person whose name is Dan loving another node. And so part here, so the node we specify as the target of that relationship, we didn't specify anything. So the whom part is just a variable for the query. It's not a persisted path in the graph. And that variable is reused in the return clause. So I call it whom. It could be foobar and return foobar. That doesn't matter, right? You can rename it as you see fit, as long as you're consistent within the query. But that's not a persisted information part of the graph. And that's a simple example of how to match a pattern from the graph, and Cypher will retrieve the data based on the data set in the database. And so, the product itself, so I've talked about Cypher, but of course, now I need to talk a little bit about what Neo4j is. It's not only a query language, it's a full database. It started actually a while ago now, 15 years ago in Sweden. Now it's, more or less everywhere in the world, in Europe, in the United States, and some other areas. is open core, so it was historically open source. Now the community edition part is open source. The edition enterprise is not open source. The open source community edition is of course available for free. Enterprise edition is closed source, as I said, but is available through Neo4j Desktop. So you locally on your own machine for development purposes, when you download Neo4j Desktop, you will get an enterprise edition. You can of course use Docker as well. So we've got official Docker images for Neo4j. You can also use, if you accept the license agreement, you can also use locally Neo4j Enterprise Edition. And so the current version is 4.4, so that's a long-term support version. And we are going to release 5.0 later this year. We are hard at work on this. So yeah, you can enjoy already, just download Neo4j Desktop, use Docker, whatever way fits you best, and you will be able to get started with Neo4j. In my case, I will use Neo4j Desktop. And about the use case, I mean, that's a very tiny subset of how Neo4j is used in the world, but maybe you have heard about Panama Papers, Paradise Papers, etc. So basically, Neo4j is used heavily in that, in those investigations, because it's very good at, unveiling relationships between a network of entities. So if you think of offshore accounts, etc., there are so many intermediate companies and people involved that sometimes it's a bit hard to visualize. But with Neo4j, that's what it's good at. So that's why you've seen Panama Papers helping the journalist actually making sense of the raw data. Really, once you organize it into a graph, it's much easier to deal with. And it's used in life science, telecommunications, and many more use cases. So I wouldn't have time to list them all, and I would probably do a poor job of that because I don't remember all of them. But really, as long as you have value in relationships you can gain from, Neo4j will help you tremendously. And so let's talk about. So I briefly talked about how you can get Neo4j for free locally, we'll see how to start a database, model your data, etc. But how do I write applications against it? So in that case, I will take the example of Go. But we have other languages as well. So we officially support 5 languages, so Java, JavaScript, .NET, and Python as well. Those drivers speak what we call the BOLD protocol. So the BOLD protocol is a network communication protocol between the drivers and your Neo4j instance. And that's what the driver does for you, basically, speaking that protocol for you, so you don't have to worry about those low-level bits, really. And what we're going to see throughout the live coding that I'm going to start now, you will see the concept of a driver itself, which will maintain a connection pool. Then you can open sessions for, when you have a sequence of actions, a logical sequence of actions, and you will open a session and run those actions. Maybe in transactions, maybe not. Those transactions may return results, which are basically sequences of records, and we will see what happens. So enough talking, let's go. So what I'm doing here, I'm doing a very small command line application. I didn't want to do anything too complex. Hopefully you can see my screen well. So I will have to create a driver, and what I do is first I will try to find movies directed by Ron Howard. Then I will try to find some information about the actress Charlize Theron. I'm not even sure how to pronounce it. And then a little fun query for the end, because we're using a graph, so let's leverage that. We'll try to find the shortest path between Kevin Bacon and Robert Zemeckis. You might have heard about the Bacon degree. Kevin Bacon is linked to many people in the industry, so that's why we talk about the Kevin Bacon degree. But first, where do I get my data set from? So when you download Neo4j Desktop, you can actually create projects and then create databases. In that case, I already started. So I will just show you real quick. So when you start, you will get access to Neo4j browser, which is a query application. So you can start playing right away. And we have online tutorials, so you could do play movies. It will go through a series of steps, and then you can import. So I've already done it, so I'm not going to do it again. But you can just click on play, import data, and then follow the exercises. So locally, right away, you can start with data sets and learn about Cypher. So I'm not going to do that now because I already have some stuff in my graph. So if I match any node and return them, we'll see I don't have an empty database. I've had a bunch of things. I have movies, I have people, etc., etc. All right, so let's get started. So the first thing I need, so if you're familiar with Go, and if you're not, let me explain. I don't have any dependencies at the moment, which is not gonna hold for a long time because I need, well, you know what, I need a driver. So the way to retrieve a dependency, so we are currently in 4.4, so I will need a v4 driver. So I will get that. All right, and currently, so 4.4.2 is the latest 4.4 Go driver. Boom, okay, I have it now. Hopefully that should resolve my problem here, nice. And the first thing I want to do is I want to create a driver to connect to the database, all right. So the package in Go is neo4j. Then I can create a new driver. And I have this config object, which basically, so you will see my password, which is really fine. Don't use that in production, but in my case, I'm just running locally, so I don't really care about clear text passwords. But I have this URI, username, password to connect to neo4j. All right, so I've got, I need a URI, and I can quickly talk about this part here. So the scheme of the URI will be neo4j, and then, there are a little more to know, but for what we're doing right now, it doesn't really matter. Then I will need a username, password, and so scheme, real in that case, I don't care. That gets me a driver or an error. So, and then because it's Go, we love to write these kind of things. If I have an error, then I stop right away. Otherwise, one thing I can do, so I could return to the driver right away, but one thing I can do instead is make sure my connectivity is not completely broken. So I can call verify connectivity, which might return an error. And in that case, I will return both the driver, because I need to close it at some point, and the error. All right, cool. So I've got the driver, so now I'm ready to play. So I've already started my database, so the localhost database is running. And let's see what I need to do then. Let's fill in the gaps gradually and get to the fun bits. So here it's panicking already. Panic to do. Oh no, what do I need to do? Well, find movies directed by Ron Howard. That doesn't work, so let's make it work. So in that case, as you can see, I have an interface and I have got an implementation, and indeed, I'm not doing anything right now. But let's also try to guide this by tests, right? It's not because it's an exotic database that you cannot test. And so in that test, what I'm using is test containers. So if you don't know test containers, it's basically a user-friendly wrapper on top of Docker. And so for that, I will need an extra dependency for my tests, which is test containers in Go. So it's available in Java, in Go, in many other languages. So I'm just gonna import that as well. All right, here we go. Then it should just work fine, perfect. So I'm not gonna go into the detail of test containers too much, but it will start a container at the beginning of my test. I will insert some data, I will insert some person, movies, and then some directed relationships, because that's what I care about. And what I want to do here is find movies. So movies have the movie label directed by a person. So let's try to do that. All right, so here we go. So what we need to do, I talked briefly about sessions. So I will need to start a session. So I've got access to the driver, which has been, passed as part of the main method. I will create a new session. I don't need any specific config, or maybe just for fun, I can specify a both logger, so that will give me at the protocol level what's going on. It's not necessary, it's a bit noisy, but it's always interesting to see. So I have a session. At some point, I need to close it, so I'm going to use defer. So when the function ends, it will automatically close this. Error handling is a bit sloppy here, but for the sake of live coding, we'll assume it's okay. And then what I can do, there are several options really I can do from here. So if I want to run a Cypher statement, so the most tempting one is run, but run is mostly useful for auto-commit stuff, which will we avoid here. Why? Because I'm interested. Let's say I have a cluster deployed, and sometimes you have a leader follower, so it's a leader follower approach. maybe I'm routed to a leader, but the leader has switched in between, then it will fail with a transient error. And I would like to retry based on that. But hopefully the driver does it for us through what we call transaction functions. We really are just transaction callbacks. In that case, I'm going to use that, and it will automatically retry if it faces some transient error. So that's the best way to go because it works well with single instances and clusters. All right, so I need a function callback. So I've got this little transaction here, and I will get some results. So in that case, what I want to do is I want to match what? So I'm interested in person. So that's a person label. The name should be something, probably going to be a parameter. So I'm using the $name here, which is a query parameter. It's like a prepared statement, if you will. Then I know it directed a movie. It directed some movies, and I'm interested in those movies. All right. And then I want to return those movies. That's all I care about. Cool. However, so then I need a bunch of parameters. So that's why I have a dictionaries of parameters that I can pass. So parameter name, so it's $name. So the name of the parameter is name. And I have director here, which will be the person name that's directed those movies. So if I do this, perfect. So that's allow me to run in a transaction automatically and automatically retry it. So I get either results or an error. Of course, if there is an error, then I will return the error directly because it's Go and we like to write those if error not nil thousands of times a day. And then what I need to do is, get all these movies. So here I'm just going to buffer them into memory directly because I don't expect a big volume of data. Otherwise, you could iterate and be a bit more smart about it. So I've got those records. Maybe something went wrong when I tried to fetch those records from the network, in which case I want again to fail. And then records. So what I want to do, because I need movies at the end, so I'm just gonna prepare my result. So I know exactly how many records I have at this point, so I can pre-allocate everything. So I've got pre-allocated thing, I can iterate over this. And then, so what I will need to do is, for each I will create a movie. And we'll see what we get there, release here, tagline, etc. And then when I'm done, I will return movies in my callback and no error. Nice. So the thing is, what's important here, my query in the end, so we don't see it, so let me close it for now, is called M. So I will need to get the column, so to say, M. All right, so let's do this. And that's going to be a node, right? Movie is a node, so that's going to give me the movie. So the movie. I'm pretty sure it exists, so it's always going to be true. So for now, I'm going to ignore the second parameter. It tells you whether that's present or not in the query result, but in that case, I'm pretty sure. We don't really have generics yet. I know there is generics in Go 118, but in a limited capacity. And so in that case, I know it's a node, right? It's a node, so I'm just going to cast it to nodes to make it easier to work with. So that's my movie node. And now, based on the tests, I will just read some properties that node. So I'm interested in movies. And if we look at movies, we have a title, we have a tagline, and we have a released date. So let's use that. So in that case, I'm just going to read properties of that node. So that's why I wanted to cast it, to have access to these. So it's a title, and because, of typing, I have to cast everything, but it will improve, with the later releases of Go, really. Then same thing here, I need the release property. And so small gotcha here, every integer is 64 bits. So it's a long in Java, or, it's 32 bits or variable length. It's always that. And tagline, again, is a string. So if we do this, we get that. So title, tagline, and it's a string, and that's how I map my result. So a bit tedious, I agree, but at least, it's an all boring thing. Nice. So if I've got an error again, even after retrying, maybe there is still an error because maybe the cluster is completely down or something, in which case I will, give up. Otherwise, I will just return my movies. But I need to cast again because, I lost the type information. That's, limitation of Go, really. And then no error. Oops, no error. All right. And so let's see if that solves my problem. Hopefully, yes, because I don't have so much time. So I hope I got it right quick enough. So you can see it started the container for me. So this Neo4j 4.4 because it's the last version. In CI, you could test against several versions of Neo4j as well. You can parameterize this. Here, I'm keeping it simple. And then I always forget a little thing here. The problem is, so my mapping works, except it expected the matrix as the first movie and the matrix reloaded as the second movie. And the problem here is I didn't really order anything. So let's try again. So yeah, I need to order by release date. That would be nicer, right? That would be more logical. So let's do that. And let's rerun this, and hopefully that will solve our issue. If not, I'm going to cheat and move on. That's the joys of live coding, right? Sometimes it works, sometimes it doesn't, and we don't always have time to troubleshoot it. So let's see. So starting the container. So yeah, container tests are nice, but they're a bit slow. Cool. So that works. We've got everything we expected. So now we can move along a little bit. So let's go back to our main function here, our little app. So it might fail later, but I should see at least the movies that were directed in my dataset. So 1 hour directed Apollo 13, the Da Vinci Code, and Frost Nixon. So that's my small data set, running against my Neo4j desktop database here. So far, so good. So next step, it still failed. So let's see why. So now I need to find one actor whose name matches. So it's going to be mostly the same, except the way we extract the results. So I'm going to cheat a little bit. I'm going to copy paste because copy paste is life and also a source of many headaches. But I'm not going to be the wiser, and I'm just going to copy paste most of it because it's the same. Open a session, run a transaction, etc. I'm just going to adapt the small bits here and there to change whatever I need to change. So in that case, so the query is going to change. I'm just gonna matching one single person. So I'm not gonna, I'm gonna be a bit sloppy. It could be a director that I match, but we're just gonna assume that I get one person. And so I need to give a variable name here because I need to return it. And the name is actually name. And here, so that's where things are going to change a little bit. So I'm going to delete all of this. At the end, I want an actor, so not movies. So I'm going to change this right away so I don't forget. And I'm just going to rename this actor. Otherwise, it looks a bit weird. Cool. So I expect a single result. Hopefully, there are uniqueness constraints on your database, but we're never safe enough. So bells and whistles here. And instead of buffering them on memory, I expect exactly one. If it's 0, it fails. If it's more than 1, it fails. And so in that case, I will get a single record, and I will need to basically create an actor based on this. So I'm going to fill all fields. Name will be. So again, I need to, before going too fast, I need to map this. I need to get P. So that's my person. I know P is in my query, so I'm going to ignore again the Boolean flag here. I'm going to map this again to a node. So it's a single record in that case, so I've got my person node. And so let's see real quick the test. So we have person, name, and born. All right, so that's easy enough, name and born. So we'll get that name property. So again, I need to cast it to a string. And then I need that born property, which will be an int64. Remember, that's true for every language we support. Integers are 64 bits. Cool. So that gives me an actor, and that should just work. So hopefully, let's see. I didn't want to spend too much time because it's mostly the same thing. Again, same container test with test containers. Starting a container, inserting a small data set into my empty database because I start with a blank container from scratch. And let's go to the funny part after that. Hopefully the test passes right away. or not. Oh yeah, so that's my last test. That's for later, but the specific test I'm interested in, so not the Kevin Bacon path, but finds by name, just passed here. So that's what I wanted to see. Nice. And let's go to the fun part. That's where, graph shine when you have some path traversal, funky path traversal. So let me see. So I still know Ron Howard traversed something. Charlize, I'm sorry, I don't know how to pronounce it. Was born in 1975, that's good. So that part works. And then the next part that doesn't work is find shortest path. So this one is going to be a bit trickier, but not that much. That's the beauty of Cypher and Neo4j. So what we want to do is find whatever is the shortest path that connects somehow Kevin Bacon and someone else. And because I like bad jokes, I call this bacon slice, but bacon slice is really what kind of node is in the middle and the name of it. So let's try to be fast because I don't have so much time, I believe. I will try to get this done. Yeah, I have 4 minutes left. Whew, challenge. So let's try to get this.
We're gonna try to have some Q&A also, Florent, so speed it up.
Sure, go ahead. I will try to do both at the same time.
Okay. Thank you for a wonderful presentation. I'll let you hack along as we go. But to the audience, please feel free to ask any questions in the chat or in the QA tab of the chat. I will try to forward them to Florent.
Yeah, of course. I'm trying to multitask here, so feel free to do it. So we want some slices at the end. So retransaction again, because I don't have so much time. And in that case, I'm going to cheat a little bit. I'm just going to copy the whole query to get it a little bit faster and explain it right away. So what we have a few functions built in the language. So yeah, the formatting sucks a little bit, but what I'm doing here is basically matching Kevin Bacon, the person that I specified through the name here. And then I'm trying to just call shortest path. So I'm using whatever path between, direct connection to 6 degrees of separation, because 6 degrees is usually large enough. And into all these paths that exist, try to find the shortest one. And that's how I'm going to find out who is connected, how they are connected in the shortest way. So if I do this, then you know what? I'm just going to cheat a lot. I'm going to go fast because I'm just going to do that. Yeah, so I don't want an actor in that case. I just want to get the single. So it's a shortest path. So basically, it's a single path that I get. I return path at the end. Shortest path is a singular. So I get a path, I get path elements, and then I get the names. So if it's a movie, it's a title. If it's not a movie, it's a name because it's an actor or director. And I basically concatenate all of this. So hopefully the test will pass. And if not, I won't have time to fix it, but I'm trying to get as fast as I can. But you can see shortest path and this kind of, intelligent algorithms. So that's one of them that's available with Neo4j, and that's all nice. So shortest path is one of the things that's really shine. You can try this in your genealogical tree, for instance, if you want to see how you are related to the Queen of England, for instance. It's always fun. So, and if I run my short demo here, and then I will go back to my slide real quick. I will have 1 minute to do so. And so the shortest path between Kevin Bacon and Robert Zemeckis. So Kevin Bacon has played in Apollo 13 with Tom Hanks. Tom Hanks played in Castaway. And I believe Robert Zemeckis directed Castaway. And that's the shortest path we have between Robert Zemeckis and Kevin Bacon. And so, yes, that was a short demo. Let me try to go back to my slide real quick. And one thing you can do, so you can download Neo4j Desktop or run Docker locally. You can run a provisioned Neo4j in the cloud through Neo4j Aura free. So once you join and subscribe, you will have access to the little interface here. You can create a new database, pick Neo4j data free, no credit card needed, and you will get an online database. And so that's how you can deploy Neo4j easily.
Cool. We actually got a question.
Yes.
Are you ready for it?
Yes. So just see the slide at the same time, take a photo, and ask questions in the meantime. I'm ready. Yeah.
Great. We got a question from Simas.
Yeah.
Any ORM to recommend to reduce duplicate and boilerplate code?
Yes, that's a great question. There is one that I know very well. So that's called, in the Go case, it's called GoGum. So it's developed by Mindstand, which works closely with us. So that will avoid some of the boilerplates. So I agree it's a bit boring, but at least it's consistent. But yeah, Gogun will save you some of the. So I'm not sure there is an example. Yeah, you can actually have some struct somewhere. Let me try to find it. My Neo4j objects, you can basically define your nodes and relationships that way. And with some annotations, it will fetch, it will instantiate those structs for you. So that's in the Go world. In Java, we have an advanced solution called Spring Data Neo4j. So I invite you to have a look at it if you're in Java world. And that also works quite nice.
Great, thanks. Time's up. Thank you so much for this session and all your bravery live coding. And I love that you actually had tests for it. Great stuff.
Thank you.
So no more questions. Everyone can relax, have a cup of, and we'll see you in the next sessions. Thanks.
Thank you, everyone.
Bye. Oh, great job.
Oof, that was short.
Fast.
Yeah.